Okay, now let us look at question 2. Okay, this one here. They're saying a hospital has 3 laboratories, lab A, lab B, lab C, which process 25%, 45%, and 30% of patient samples respectively. Okay, so this simply means that from lab A, you're going to get 25%, lab B, you are getting 45%, lab C, you are getting what? 30%. Okay, and then they're saying of the samples processed by lab A, lab B, and lab C, 4%, 3%, and 2% are contaminated respectively. So this means that from those samples that are processed by lab A, 4% is contaminated. Those samples that are processed by lab B, 3% is contaminated. And then those samples that are processed by lab C, 2% are what? Contaminated. Okay. And then the first question there, they're saying, what is the probability that a sample is processed by lab B given that it is contaminated? Okay. So we have been asked here to find what we call as a conditional probability. Okay, because we have been strictly given that the sample is contaminated. Okay, so what is the probability that the sample is processed by lab B given that it was contaminated? Okay, so for us to easily solve this question, we're first going to come up with a tree diagram. Okay, so remember we have 3 labs, and then lab A processes 25%, lab B 45%, lab C 30%. Okay, and then of those, we have those that are contaminated, and then we have those that are what? Are good, are not contaminated. Okay, so let's come up with a tree diagram for this. Okay, so we had lab A. I'm just going to write A here. Okay, lab A, we were saying that 25%. So this 25%, guys, is just the same as 25 divided by 100, which is going to give me what? A 0.25. Okay, then lab B, we were told it's 45%. 45% is the same as 0.45. Okay, C, we were told that it's 30%. So this 30% is the same as 0.30. Okay, in decimals. Okay, so now let's come up with a simple tree diagram. So if this is my starting point here, I'm going to draw 3 lines from this starting point. Lab A, okay, lab B, and then I have what? Lab C. Okay, so what is the probability of something coming from lab A? We're told it's what? 0.25. So I'm going to write lab A here. Then what is the probability of something coming from lab B? It's just 0.45. So I'm going to write 0.45 here. Then what's the probability of something coming from lab C? Okay, to just be 0.3. Okay, and then we were told, okay, we were told in the question that from lab A, okay, there is a, from lab A, there is a 4% chance that you're going to get a contaminated sample, okay? From lab B, it was 3%, and then from lab C, it was 2%. So it means from here, we're going to draw another branch like that, okay? We're going to say this is contaminated, and then this is good. Even here, we're going to do the same. We're going to have the one that is contaminated, and then the one that is good. Okay, even here, we're going to have the one that is contaminated, and then the one that is good. Okay, so if a sample is processed by A, there is a 4% chance. Okay, let me write. There's a 4% chance that it is contaminated. Okay, so this 4%, if you put it in decimals, just divide this 4 by 100, it's going to give you 0.04. So there's this chance of 0.04 that it will be what? Contaminated under the C there. Okay, and then what is the probability that it is good? Okay, since 0.04 is the one that is contaminated, okay, then the rest should be good. Okay, so how can you find that? You say 100% minus 4%, you're going to get a 96%. And then that 96% divided by 100, you get what? 0.96%. okay, of it being good if it's from A. Okay, and then what was the percent of it being contaminated if it comes from B? It was 0.3. I mean, it was 3%. Okay, so 3%, when you put it in decimals, it will just be 0.03. Okay, it means the rest is good. Okay, so the rest will just be 0.97. Okay, and then what's the probability that it's contaminated when it comes from C? Okay, from C. We were told that it's 2% from the question. So 2% is the same as 0.02. Okay, so what is the probability of it being good? You just subtract 1 minus 0.02, you're going to get 0.918. Okay, now let us look at the first question. So the first question here, what's the first question? It's saying, what is the probability that the sample is processed by lab B, given that it is contaminated? So here, remember, we're finding conditional probabilities, right? So we want to find the probability that it comes from lab B, given that it is what? Contaminated. So you have to know the definition of this, or how to interpret this guy here, okay? So if you have, let me write it here. If you have the probability of B given C, okay, probability of it coming from lab B given that it is contaminated, this here is the same as the probability of B intersection C, okay? And then we're dividing all this by the probability of what? C, okay? So the probability of C is just the probability of it being what? Contaminated. Okay, and then this is just the probability of B. Okay, so we have to find the probability of B intersection what? The probability of B intersection C. Okay, so how can we find that? Okay, so if you go back to your tree diagram here, the probability of it coming from B and being contaminated is just multiplying this 0.45 multiplied by the what? 0.3. Okay, so let's put here that the probability of B intersection C would just be equals to 0.45 multiplied by 0.03. Okay, so if you punch this on your calculator, you should be able to get 0.0135. Okay, so we have one of the things that we need in order to find this probability here. So the remaining thing now to find is the probability of what? It being contaminated. Okay, so how are we going to find the probability of it being contaminated? We're going to add the probability of it coming from lab A, given that it is contaminated, plus the probability of it coming from lab B, given that it's contaminated, plus the contaminated of it coming from lab C, given that it is what? Contaminated. So we're going to say this multiplied by this, plus this multiplied by this, plus this multiplied by this. That is what is going to give us the probability of it being what? Contaminated. Okay, so we are going to say here, 0.25 multiplied by 0.04. This is the probability of it coming from lab A and being contaminated, plus the probability of it coming from B and being contaminated is just this thing that we can see on top here. So I'm going to say 0.45 multiplied by 0.03. And then plus, okay, the probability of it coming from lab C and being contaminated would just be simply 0.30 multiplied by 0.02. Okay, and then you punch this on your calculator. What are we going to get? Okay, I'm getting 0.0295. Okay, so this is the probability of what? Being contaminated. Okay, and then this is the probability of it coming from lab B and being contaminated. So we can replace, because we find the value of this guy, we've also find the value of that guy. Okay, right, so it means that the probability of it coming from lab B, given that it is contaminated, will just be equals to the probability of B intersection C, okay, which we found that it was what? 0.0135 divided by the probability of it being contaminated, okay, which we found to be 0.0295. Okay, so just get your calculator, punch in that value. Okay, we are going to get the probability as 0.4576. Okay, so this one here is our first answer. Okay, the probability of it coming from lab B, given that it is what? Contaminated. Okay, so this is how we find it. And then the next question now says, this one on B, they're saying, what is the probability that a sample is not contaminated, i.e. it is good, okay, or it is processed by lab C? So we know that this or here simply means the union of the probabilities. So we want to find the probability of it being good, and then we unionize it by the probability that it was processed by lab C. Okay. Okay, so how can we find the probability that the sample is not contaminated? Okay, so we're going to use the complement rule here. Okay, so let's, I'm going to say let maybe G or any letter of your choice. Let G, no, G would, okay, yeah. So let G mean that it is not contaminated, which is good, right? Okay, which means that the sample is good if it's not what? Contaminated. Okay, you can finish the spelling there. Okay, so we want to find the probability that it is good, okay, union, the probability that it was processed by lab what? C. Okay, so now this C that will be writing here is not the one for contaminated, it's the one for lab C. Okay, so I'm going to say C. So we know that by the union of two probabilities, this will just be the same as the probability of G plus, okay, probability of C, and then minus the probability of G intersection what? C. So this is the probability of it not being contaminated, which means it is good. So how can we find this? So the probability of it being good is just equals to, okay, 1 minus the probability of it being what? Contaminated. So differentiate this C for contaminated and this C, that means it comes from lab C, okay? Right, so this will be equals to 1 minus, what did we find to be the probability of contamination, okay? If I can go back here, we found that the probability of it being contaminated was this guy. So for us to find the probability that it is not contaminated, we're just going to do 1 minus this value, okay? So this is what I'm doing here. So it will be 0 point, okay, so 0 point, what did we have there? Okay, 0.0295. Okay, and then we subtract this. What are we going to get? Okay, let me just punch this into my calculator. So we have 1 minus 0.0295. Okay, so I'm going to get the probability of the sample being good or the sample being not contaminated is just 0.9705. Okay, so I have one of the things that I need, which is this one here, probability of G. And then this one here means the probability of it coming from lab C. Okay, so the probability of it coming from lab C we were given in the question. Okay, so the probability of coming from lab C was what? 30%. And then 30% divided by 100 is just going to give you 0.30. Okay, so now we're remaining with the probability of it being good intersection what? Coming from lab C. Okay, so how are we going to get this probability here? We are going to get it from that thing that we drew here. Okay, that's where we come up with that probability. Okay, so if you go back there, This is what you're going to find. Okay, so one, find the probability that it is not contaminated, and then it comes from lab C. Okay, this is the G intersection C. Okay, so if I come here, where's the yeah, so this tree diagram here. Okay, so the probability that something comes from C and it is good, okay, it is just 0.3 multiplied by what? 0.98. Okay, so this is the probability that it comes from C, and then this is the probability that it is good, okay, and it's coming from C. So meaning the probability of, let me write somewhere here. So the probability of it coming from lab C intersection good, okay, you can also write this as good intersection C, is just the same, is going to be equals to 0.3 multiplied by what? This 0.98. So this is going to be what? Okay, so you get your calculator. That's right. It is 0.30 multiplied by 0.98. Okay, so if you multiply those, you're going to get 0.294. So this 0.294 is the one that I'm going to put there, where we have the intersection. Okay, so if I come back here now, okay, this probability of G intersection C or C intersection G is just simply 0.294. Okay, so now we have everything that we need in order to find the probability of it being good or being contaminated. Okay, because we have this value, which is this guy, we have this value, which is this guy, we have this value, which is this guy. Okay, so now let's substitute into the formula. So it will be probability of it being good union contaminated is just equals to the probability of it being good, okay, plus the probability of it being the probability of it coming from lab C, then minus the probability of the intersection of it being good and coming from lab C, so which is 0.298. I mean 294 there. Yeah. All right, so let's punch this into your calculator and then you'll be able to get the final answer there. Okay, so final answer, if I punch this in my calculator, I'm getting, okay, I'm getting 0.9765 as my final probability. Okay, so this is the answer on what? B. Okay, so we go to the next question now.